Hello friend, I am Naval. You are watching Code with Naval. Welcome to 𝗧𝗢𝗣𝗑𝗏 part 93. In a last video, we saw collection utility classes. In this video, we are going to discuss about a map interface. Map interface is not child interface of collection interface. That's why it's a little bit different. Till now we saw collection interface and they are all implemented classes. And there we observe, there we store only value. There we don't have any option to store a key, and those values store internally against index value. Okay, but now I have a requirement. I want to store 1000 employee data against their employee ID. Then how can we store? For that we need something. There we can store a key, and key as a employee ID and value as a other data. This map provides that features. Here we can store a key and value. Let's discuss map. Here map introduced in a 1.2 Java version, and along with that introduced in a 1.2 HashMap, WeakHashMap, then introduced 1.4 IdentityHashMap, LinkedHashMap, and here we have some interfaces: SortedMap, NavigableMap, and then TreeMap. And here we have some legacy classes: dictionary, hash table, and property. These legacy classes means this one is a old classes, those introduced before a map concept. These classes introduced before a map concept. That means this map introduced in a 1.2 and these classes introduced in a 1.0 version. That's why we call those classes legacy classes. Okay, here we have a legacy dictionary, then hash table. This t should be small. Okay, this t is not capital. Okay, hash table, then property. Okay, let's discuss one by one. First we discuss map and hash map. Map interface is not a child interface of collection. A map contains a value on a basis of key. Example, key value pair. Each key and value pair is known as an entry. A map contains a unique key and it can contain a duplicate value. Here we have to store a unique key. Okay, if we try to store a duplicate key, then it will simply override that. Okay, because here we don't have add method. Here we have a put method. Put method simply update value. Then here we can contain a duplicate value. There is no issue. We can contain a duplicate value, but we can't contain a duplicate key. Map allow one null key and multiple null value. Here we can store one null key and multiple null value. Map is useful if you have a search, update, or delete element on a basis of key. If we have a frequent operation, if we want to store a database on a key, and if we want to perform some operation, if we want to perform a search, update, delete operation, then we can use a map. Let's consider example. We can store 1000 employee data. Okay, and then against employee ID we have to update record, we have to delete record. Against employee ID we can perform easily that, because here we can store as a key employee ID and other detail as a value. Then here few common method. Map interface provide all common method, those used in all child classes. Here have a few child interfaces: SortedMap, NavigableMap, then child classes HashMap, WeakHashMap, IdentityHashMap, LinkedHashMap, and TreeMap. You can see in this diagram here list. This list is a part of a collection interface. Okay, this list is a child interface of collection interface, and this part of a collection interface. Here storing a value against index, and index is auto increment 1 2 3 4 like this. It increment continuously, but I want store a data key value pair. Then here we have a map. Here we can put our own key and own value. Okay, we can simply put in a key 2 I want to store A, key 1 I want to store B, 3 C, 4 D. Okay, in this way we can store a key value pair. Okay, let's discuss first implementation class HashMap. HashMap is the implementation of map. It doesn't follow any order. It internally uses object hashing. Okay, every object have a hash code and it internally using that hash code for store data. It hold a unique key and duplicate value. Map interface don't have a add method. It has a put method. and it's work like add and update. If already present that value, then it will update, and if not present, then it will add. Here you can see we can simply create a object, HashMap object, and we can put here value. Okay, ss dot put, and we can define here key and value. Key is an integer and value is a string. Okay, let's open Eclipse and I'll simply create here one class. Okay, let's create a class name is a part 93, and here we create a one main method. Okay, let's create here main method, and inside the main method let's declare a map. Okay, here you can see here we get a option key and value. Here we have to pass a key and value. Okay, let's open a declaration and let's check what inside this map. This map introduced in a 1.2 version. Along with that, you can see here we have some classes: HashMap, TreeMap, HashTable, SortedMap, collection. You can see all these things present here. If you check all this map method, here we have all common method. Those we can use all implementation classes: size, is empty, okay, put method, remove method, clear method, key set. Okay, all these common method. Few of them introduced in a Java 1.8 version. You can see this method introduced in a Java 1.8 version. In a Java 1.8 enhancement happen in this map, or we can say collection part. Okay, we will discuss all this new method in a Java 1.8 series, because these are a huge part and we can't cover all thing here. Okay, so let's create here one. Okay, I'll simply put here as a key string and as a value also string, and let's create here ss equal to new hashmap, and here we can pass a also string. Here we create a ss, and we'll simply by using a put method, because here we have a only put method. Here we don't have a add method. You can see here you don't get add method. Here we have a put method, and inside a put method we can pass key. Okay, I'll simply pass a as a key and value as a capital A. Okay, let me add all few record. Okay, let's see. Here we added a few record. Here we first add a key and a value, then c, then d, then bb, then one add a null value. Okay, let's print this. Let's see what output get. SYSO, and let's add here ss. Let's save, run this. You can see here we get a null, then a, then b, then c, then d. Okay, because here internally follow object hashing. Okay, here don't follow any insertion order. Here internally follow object hashing, and here we can see here this key accept null value also. Let's try to add two null. Okay, here I'll simply, instead of this d, I'll simply add here two value as a null, d and b. Here this key value is a null. Okay, let's save and run. Here you can see this null, and let's try two time null. Let's save and run this. Here you can see this one is a simply override this entry. Okay, whenever we try to insert already inserted record, already this key have already value, but if I try again add data. Okay, this a already have this a capital A, but here I am trying to again add a data. Okay, a, then save, then run this, and here you can see this a simply override here. Okay, initially this a key have a value, then we simply override here a is a. This put method is work like a add and update. This first time this put method don't have this a key, then this time this one work like a add record, and this second time this put method already get this a value. This time this one work update. This time this perform update. Okay, this put method perform if already record already key not exist, then it will add. If already exist, then it will simply update that key value. Okay, We have a few more method. Let's try those method. Okay, I'll simply write ss dot. Here you can see if we want to get any value against key. Okay, I want this key value. Okay, I'll simply pass here c, and let's see, save, run, and here you can see, here we get a this, here we pass a key, and here we get a that key value. Okay, because this map concept very useful when we have a search operation, when we have a update operation. So let's try to update. Here you can see this one is using like a update, but we have a few more method for update. ss dot, here you can see replace method also. Here we can pass a key and value, and here also we can pass a key value with old value. Okay, and this old value replaced with a new value. Okay, then here we have a this replace method. Here we can only pass a key and value, and it simply override already existing. Okay, so this all thing provide this map. Let's check how many constructor provide this hash map, and here we get the idea. Here you can see this constructor, this hash map provide a 4 constructor. First one is a default, and then second one is the initial capacity. Here we can pass a initial capacity. Then third one, here we pass a any other hash map object, and this fourth one is a, here we pass a initial capacity and load factor. If you watch continuously my video, then you already know what is the initial capacity, what is the load factor. Okay, if you don't watch, then no worry, I'll simply show you here in a shortcut. Okay, let's open this hash map and let's press Ctrl O, and here you can see, okay, let's press Ctrl O, and here you can see default initial capacity, and here you can see default load factor. Okay, let's open this default initial capacity. Here you can see 16 is the default initial capacity, this hash map, and load factor is a 0.75. Okay, when this 16th 0.75 complete, then it will create a new map, and it will put all old map value in a new map, and it will reassign a variable. Okay, then here we have a other thing also, threshold value, all these things. Here you can check and read this all this comment, and you get a better idea. Okay, so here we understand, here we can put a null value, multiple null value. It's possible, but when we try to add a duplicate key, then it will simply override, it will simply update that key value. Okay, so in this video that's it. We will see next topic in the next video. Till that, bye bye.